All right, this is Mr. Slaney's video on the quadratic formula with a special emphasis on the discriminant, which is really this chunk right here, b squared minus 4ac. Let's see a quick example of how to use a quadratic formula, what it's ultimately there for, and then I will talk about what exactly the discriminant is used for. Let's take this away. Actually, get that a little higher. Yeah, that's good. All right, here we go. Let's say that you're walking in the wild, and bam, there is a quadratic equation. Plus 8 equals 0. Quadratics, of course, defined by the key feature, this square right here, being the highest exponent. Now, obviously, we could just factor this bad Larry. You get x plus 2, x plus 4 equals 0. The zero product property tells us that x must be -2 or -4. That's easy. But sometimes we can't factor, or factoring would be a real bee sting, real pain in the butt. So let's take a look at the quadratic formula again. Ax squared, if, there should really be an if in there. What is this, amateur hour? If ax squared plus bx plus c equals 0, then x must be -b plus or minus the square root of b squared minus 4ac, all divided by 2a. That means that we can take the coefficients of x squared, the coefficient of x, and the constant term in the quadratic equation, plug them into this thing, simplify, get some numbers, and we will have our solutions. Let's see what that looks like. With this. So here, I'll go a little bit lower. X squared plus 6x plus 8 equals 0. I really like to identify my variables before I do anything. So I'm just going to write a equals 1, b equals 6, and c equals 8. Keep in mind that there is an invisible 1 here that we don't write. The other tricky thing can be if there simply were not a constant term, or if there were not a number multiplying by the x, then you would have 0 be the coefficient for b or c. So 1s and 0s you always got to tread lightly for. At any rate, let's plug these into my mess that came before. What color? I have so many pens. I've got 2 red pens open. I'm just going to put that away. All right, -b plus or minus the square root of b squared minus 4 times a times c, which is 8. Now, just all over 2 times a. Now, this is just my style. I like to put the 1 in parentheses, but whatever thing is here, I put on the outside of those parentheses. Give me 1 second. I'll be right back. There was a cat at my feet, and I had to make sure they were gone. Let's simplify this bad boy, because writing this out is its own chore. Actually solving it, nothing we can really do with the -6 right now. Plus or minus stays on the inside. I'll square the 6 for 36. Multiply 4, 1, and 8 together. 32 and 2. Now this can obviously get a little stickier if I've got any of these being negatives. Right now, my coefficients A, B, and C are all positive, so that makes life a little bit easier. But just to underline the point of how to use them. All right, let's keep going. -6 plus or minus. Again, we can't really do much else. Let's just focus on the inside. Always better to think less and write more, especially with this thing. Just do the smallest amount that you can. -6 plus or minus 2 divided by 2. All right, now that we've finally done the square rooting, we figured out what's going on with the discriminant, funny enough. Now we're going to split into the two cases. One of these will be -6 plus 2 divided by 2. The other will be -6 minus 2. Uneven coloring scheme. Minus 2 divided by 2. All right. -6 plus 2 is -4 divided by 2 equals -2. -6 minus 2 is -8 divided by 2 equals -4. All right, so all that, and don't forget x equals up here, equals. Ugh. All that to replicate this. Now, what's nice about the quadratic formula in general is that we can use the quadratic formula no matter what our equation is that we're trying to solve. I'm just going to write a random one. Let's actually, let's write another one. And right away, before I even think about this, I'm just going to write out my variables. A equals 1, B equals -8. Ooh, negative number. C equals 15. All right. Now, what is the discriminant and why do we use the discriminant? Okay, using the discriminant. Discriminant. Did I spell that right? Probably not. That's a C, not an E. The discriminant is just the chunk b squared minus 4ac. And what this tells us is that if we were to use the quadratic formula, so if we were to plug this into our whole thing before, depending on what this value looks like, I can know the number or the type of solutions. There's 4 cases. But let's see what happens here. And again, you might be staying woke. I scream at my children at school. Anytime you see a quadratic, you should instantly be trying to factor. Luckily, this bad boy factors into x minus 3, x minus 5 equals 0. So x must be 3 or 5. Again, easy to solve. But let's look at how the discriminant works. Here we've got 2 solutions. The discriminant here, b squared minus 4ac. Let's see, -8 squared minus 4 times 1 times 15. Again, just my style to put this bad boy in parentheses and then leave that out there. -8 squared is 64 minus 4 times 1 times 15 is 60. I'm struggling with my equal signs today. Equals 4. All right. And here's how we would use the discriminant. 4 is a perfect square and 4 is greater than 0. Because 4 is greater than 0, x squared minus 8x plus 15 equals 0 has 2 rational solutions, right? That's how we would use a discriminant. Are there 2 solutions, 2 imaginary solutions, no solutions? And how we answer that question all depends on what kind of a number we get out of b squared minus 4ac. Let's look at a trickier case. Okay. Oh, I've got a good one. I'm just going to... So, ultimately, if the discriminant is positive, you've got 2 solutions. let's look at x squared. I'm going to start moving a little fast now. Plus 6x plus 9 equals 0. Again, if you're staying woke, x plus 3 squared equals 0, x plus 3 equals 0, x equals -3. One solution, right? One nice clean, this is a perfect square quadratic. A equals 1, B equals 6, C equals 9. So right now I've just done all the easy stuff. I checked to see if I could factor this. 3 adds up to 3 plus 3 is 6, 3 times 3 is 9, so I could factor this very easily, and then I wrote out my coefficients. Now, let's see what happens when I plug this into the discriminant. Let's change the color of pen. 6 squared minus 4 times 1 times 9 equals 36 minus 36 equals 0. So now that tells us that if the discriminant, we should learn now, if the discriminant is 0, then the quadratic has one solution. All right, if I were to write this, I'm not going to write this out every time. This video is already 11 minutes long. My gosh. So we check to see here the discriminant was positive. It's also worth mentioning that 4 is a perfect square, so I have two rational solutions. If my perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, all things that are the result of squaring a number. 3 squared, 4 squared, 5 squared, 6 squared. Yeah, I could keep on going forever. There are infinitely many perfect squares, but these should all, if your discriminant is equal to any of these, you have two rational solutions. If my discriminant was like, if D equal, my discriminant, if I did B squared minus 4AC equals, I don't know, anything but one of these. What's a number that's not a number here? 10. Then my quadratic would have two solutions still, because I can technically take a square root of 10 while I was doing B squared minus, the whole bit. But I would just, square root of 10 isn't really a thing, Square root of 10 is just square root of 10. You could plug that into a calculator, get a decimal, prove me wrong. An engineer could cut up a log to be 3.1 something inches or whatever the case might be, and the world would be fine. But your solution would be irrational. You'd have a radical. Let's look at the third case and let's wrap this bad Larry up. Give me 1 second. Think about this. And let's do 2x squared. Oh, let me be a tricky goose. I'm just going to do something outrageous here. Plus 10 minus 2x equals 0. And now, if you really wanted to solve this, you could divide everything by 2 and then do the whole bit. But let's just take this at face value. First thing that I did was I put the x term over here. B is still -2 because B isn't the last number that's there. B is the number that is multiplying by x when your equation is in standard form. Standard form for this bad boy would be 2x squared minus 2x plus 10. So B is still -2. Ugh. A is 2, our first one where that's, not 1. C is 10. Let's look at the discriminant. -2 squared. Notice how I'm putting that in parentheses. -2 squared is -2 times -2. You'll get a positive. Minus 4 times 2 times 10. 4 minus, let's see, 8, 10, 80 equals -72. I was about to say, do I have my phone? Nah, I'm using my phone to record. Now, this implies that I won't have any, I will have two imaginary solutions. Let me show you what that means. Let's just plug all this in to the quadratic formula. So I would have negative, -2. And I am going to write negative with parentheses. I'm extra, but you know what? If you write more, you will have to think less. And I don't care if your hand gets tired. You won't get stuff wrong. You'd rather have a tired hand and a better grade. Plus or minus -2 squared minus 4 times 2 times 10. All over 2 times 2 now. -2 is +2, plus or minus the square root of -72 over 4. The square root of -2. If this were a multimedia YouTube channel, I would show you on the internet, or I would, if I had a calculator. Do I have a calculator? Does this? Oh, yes, I do. What is this? Does it have square roots? No, it doesn't. Wait a second. I have two calculators. Holy guacamole. Ugh. Can you see it? The square root of -72. Can you see it? All right. Here we go. Enter. Domain error. Your calculator will not do that. Now, an imaginary number is something related to I, which is a whole separate issue. For now, for the purpose of this video, if your discriminant, which is just b squared minus 4ac, is negative, what you need to know is that 2x squared minus 2x plus 10 equals 0 has two imaginary solutions. And that's it. So let's just revise. Retelling a story. This is the quadratic formula. You can use this to solve any quadratic. You can use this for the rest of your life. I use it like 2 or 3 months of the year. And then I let it go on vacation. Like, it's exhausting. And I do some ugly stuff in trigonometry. This is what it looks like to use the quadratic formula to solve something x squared plus 6x plus 8. Everything's positive. Everything shakes out. Notice that my discriminant is positive, and I had two rational answers, right? Two answers that did not end in never-ending, non-repeating decimals. -2, -4. This is the case where the discriminant was positive. I have two rational solutions to the equation. We also talked about on this page, if my discriminant, rational is that word, right? Rational solutions, imaginary solutions. Rational solutions are like actual numbers. And again, now I have a calculator. I can show you if your discriminant was something like what was something like +5. The calculator won't even do it. Let me do classic. Boom. Look at that. And it gets worse. This answer actually goes on infinitely, so it's a real bee sting. You don't want, it is what it is, right? As long as your answer is in some sort of perfect square, as long as your discriminant, b squared minus 4ac, is not some perfect square, you have two irrational solutions. If your discriminant is 0, you will have one solution. If your discriminant is negative, you have two imaginary solutions. And again, this is how you do the homework for that one very special child. It's not even my student. All right. Good night.